So guys, let's start. So we have very low participants today, but we have to take it in time. So let's start. So last week, what we have done is that we have discussed regarding EC2. Okay. So regarding EC2, what we have done is what is EC2? What we have seen that we have configured EC2 instance on Ubuntu server, and we have seen regarding access keys, how we can connect a Ubuntu server. We have seen that. We have created EBS volumes, and we have attached EBS volumes in the Ubuntu server. So we have already, I have already shared you the commands on how to configure an EBS volume in Ubuntu server. So these are the things, and we have seen what is a snapshot. Okay, we have seen how snapshot works. Okay, so these are the things which we have done last week. Today we will be working on something. There are certain portions of EC2 which are left. So for EC2 we will be working. We will be configuring a Windows server. Okay, we'll see how we can access RDP connections. Okay, we will create snapshots of that Windows server. We will see how we can create an image from a snapshot. We will see how we can create a custom AMI or Amazon machine image. Okay, we will see how we can deploy a custom AMI. Once that is done, then we will be jumping into ELB or Elastic Load Balancer. Okay, we will see what is ELB, types of ELB. We will then see how we can deploy a classic ELB and a network ELB. And if time persists, we will also see how we can deploy a application ELB. Okay, so this will be the topic for today. So to start with, let's deploy one Windows server. Okay, so in this particular environment, we will be needing to show the entire hands-on lab for today's session. We will be needing 4 EC2 instances. Okay, so we will be needing one Windows EC2 instance, and we will be needing 3 other instances. We will see, because in order to show the elastic load balancer, we will have to deploy 3 instances. Okay, 3 different applications, 3 different instances, and 3 different EC2 machines, and we will see how we can do that. So all those machines will take some time. So let's first, before starting with the actual session, let's start building the instances. So first let's build a, so let's go to the new EC2 experience. Click on launch instance. Let's launch a Windows instance. click on select, T2 micro, next configure. Okay, let it remain the same. We don't need anything. Next add storage. We have a 30 GB of storage. Next add tags. Next add security group. We have 3389 already added. Let's add HTTP as well to anywhere, and let's add HTTPS as well to anywhere. Okay, review and launch. Okay, so let's create an existing key. So let's create an existing key, download key pair. Launch instance, new instances. Okay. So this will be Windows instance. Let's launch another 3 instances for this. So what are the instances that we need? We need an instance, like say, let's deploy a WordPress instance. Okay. So WordPress is actually an application or an instance with the help of which we can deploy websites. So currently in the entire world IT scenario or building of websites, WordPress is actually capturing approx 40% of the market share. So most of the websites which we've seen were actually created in WordPress. So let's create a WordPress instance first. Continue. Click on T2 micro. Configure instance, review and launch. Okay, so let's create ELB. Okay. Launch instance. New instance. This is known as WordPress. Let's launch another instance. Let's say let's launch Joomla. So Joomla is actually a content management software. Okay, so we can deploy Joomla to show how we can work on the ELB functions, how the load can be distributed between this WordPress and the Joomla instance. So let's deploy a Joomla instance as well. Micro, configure instance, review and launch. Let's take this RSA only. I acknowledge launch instance. Okay. And lastly, let me tag this with Joomla. And last, what we need is another instance in order to show you the network load balancer. Let's go for Tomcat. Okay, so by the time this instance will take around 5 to 10 minutes of time for the entire deployment to happen. By the time these instances are getting launched and getting provisioned and getting launched, let's go to our whiteboard and annotation mode, and let's see what are the things that we will be teaching today. Okay, so we will be showing how, we have already seen what is a snapshot. Okay, So first, we have already deployed a Windows instance which is on the verge of getting provisioned. We will see how we can go for an RDP access. Okay, so it is pretty much easy. Like you guys may be thinking that what is important in showing how we can access on Windows instance. It's a simple RDP and MSTSC, and we can access it. Yeah, but definitely we can do it. But the reason to show you is that like Azure or in Google Cloud, it is not easy to get the password for which the help of which administrator account will be connected with the RDP. So I will just show you how you can get that particular password, and then we will deploy a Windows RDP instance. We will log into that Windows server. We will deploy a IIS over that. We will create a snapshot of that particular Windows server, and after Windows server is particularly created, we will see how we can create an image to deploy multiple other instances of the same server. Okay, so WordPress is already deployed. Okay, so let's see how it looks, how the WordPress will look like. So let's copy the public IP address over here, and if we press the public IP address, it will try to put the public IP address in the browser. So I think it still needs some time. Fine, so let's go to my whiteboard, and let's see what we can do with. Okay, now, so what we have done is that we have deployed a Windows server over here. Okay, so this is a Windows server. What we will do is that we will take a snapshot of this Windows server. Okay, and then we will create an image of this Windows server. Image will be created for this Windows server. We will create an image, and then we will see how we can create custom AMIs on this image. Now, what is the reason for, what is the requirement of creating a custom AMI? Now, in a normal scenario, or in a actual scenario, you have to deploy, like if it's an EC2 instance, okay, and suppose you want to deploy a web server, okay. So what you have to do is that you have to deploy multiple web servers, right? So you have to deploy numerous web servers, maybe 10, 20, 50 web servers that you have to deploy. Now, in order to deploy these web servers, so what you will do is that this is the first web server that you will be configuring with the application and maybe with the database connectivity and everything you will configure in this first web server. And then if you want to deploy the same applications or same web server into other 50 instances, so definitely you will not go manually and deploy all those instances manually, right? So there are two options with the help of which you can deploy multiple instances of a same server. First, you can create an image of this particular server with the applications and with other database and everything pre-configured. And then once this image is deployed, once this image is created, we can deploy these particular servers, keeping this from this particular image. So instead of checking, or instead of searching the instance type from the EC2 management console, we can directly go to the custom AMI. We can directly create an AMI of it. So the AMI is Amazon machine image. Okay. From the snapshot, we can create a AMI. We can take this particular AMI and we can deploy this AMI into multiple servers. This is one. Okay. Even this procedure is also not followed in a actual environment, in a production environment. So what happens is that we create an AMI from this particular image, from this particular server, the pre-configured server. Once this AMI is actually created, we use a tool which is known as Terraform, okay, So Terraform is actually a scripting tool with the help of which what we can do is that we can create a particular script, and that script will actually collect this AMI and will start deploying all the servers. Okay. So this is the actual procedure which is followed in a production environment or in a big infrastructure where you are configuring multiple servers. So we will take the applications, the configurations, whatever the things that you have done, we will take all those informations from this AMI, and rest other configurations, that is the machine name, the IP addresses, the VPC it will belong, the security groups that the security group rules that it will take. So everything we will all configure in the Terraform, and Terraform will deploy this AMI image into multiple servers. Okay. Now, in order to do that, let's go back to our console. Let's see what is the state. Okay, my Windows machine is running. Everything is running. Fine. Let's see if now it is accessible or not. Okay. So this is the classic WordPress launch page. Okay. And if I go to the Joomla server, if I copy this is the classic Joomla page, Joomla index page. This is the classic Joomla web page which we will be seeing in this. Okay. Now, in order to do an RTP session, okay, so what you can do is that you can select this Windows image like the same way. You can click on connect. Okay. You can then go to RTP client. Okay. You can now use the same EMI. If you want to click on this get password, you have to get the password, right? So click on get password. Okay. We have already downloaded the key pair with the help of which we have created this Windows machine. Click on browse. Okay. Select that particular Windows key pair. This is the Windows key pair that we are talking about. No, sorry. This is the key pair. Yeah, this is the key pair that we are talking about. Click on this cloud.pem, click on open, okay, and then click on decrypt password. So this is the Windows password that I am talking about. Okay. Now, in order to access this, go to MSTSC, click on the public DNS, and click on connect. Okay. Use administrator and click on this password. Give the password. Click on OK. So this is the Windows 2019 machine. What we will do is that once this Windows 19 machine is logged in, we will install IIS over this Windows 19 machine. Okay, and we will create a web page, or we will see whether the default web page of IIS is actually coming up or not. If it is coming up, then we will create a snapshot of this Windows machine, and we will try to create an AMI out of it. Okay. So in order to in order to create a web page, you someone is on unmute, I think. Okay, thank you. So in order to create a web page or in order to deploy a website over Windows, we need to deploy IIS. Okay. So IIS can be deployed by two ways. Either you can go to Server Manager. Either you can go to Server Manager and deploy the IIS role, or you can also do the same with the help of PowerShell. Okay, so in the PowerShell, just write install hyphen Windows feature hyphen name web server hyphen include management tool. So this is the command with the help of which you can create or you can install IIS over Windows. So I am sharing you this particular command so that at the time of your hands-on you can practice this. Okay. So now my IIS is installed. Yeah, IIS is installed. Let me see. Yeah, IIS is installed. How we can see that whether the IIS is installed or not? So in order to see that, just open the page. Click on localhost. So let us wait for the IIS to get installed. So it will take some time. Okay, so the installation is now complete. Click on close. Okay, now let's go back and let's see whether now the IIS is properly installed or not. http://localhost, and we can see the classic internet IIS web front page. Okay, similarly, if I go back and if I select this, if I select the public IPv4 address, if I go and paste it over here, it will show me the internet IIS page. Now suppose you have configured IIS, after that you have configured numerous other applications as well. Okay, so you have configured the entire application which will be accessible over the web. You have configured the database connections. You have configured all the things that is required, or maybe suppose if this is a database server that you want to configure, so you have installed the related database, maybe SQL or Oracle or whatever may be the database that you want to use, and now your server is actually up and running with the latest applications and everything. Okay, but definitely in your environment you will not be requiring a single server to run your database or application, right? So you will be needing multiple other servers in the cluster which will be running the same application and the same database, and it will be working as a primary and a secondary scenario. So in order to deploy that, how we can do it, so let's just log off from here. So how we can do it, let's go back to this management console and then go back to snapshots. Let's take a snapshot of this just remove, let me remove this action, delete, just so that we don't confuse with the thing. So let's create a snapshot of this. Click on create snapshot, click on instance. So we will be taking the snapshot of this Windows instance. Okay, this is the volume, and then we will be giving a name like win snapshot. Okay, and then click on create snapshots. Okay, so this is pending. It will take some time for the snapshot to create. Once the snapshot is actually created, then what we can do is that we can create an image from this particular snapshot and use that particular image or the Amazon or AMI, which we call as custom AMI, and we can deploy that custom AMI into multiple other machines. So I will show you. Let's the snapshot be created. By that time, my Tomcat is also up and running. So let me see whether my Tomcat is running or not. This is the public IP address. Yeah, my Tomcat is also running. Fine. So I have 3 servers which are running. Now, can anyone tell me what will happen if I shut down this particular server? Shall I get this public IP address? Can anyone tell me if I shut down this particular server? It will change, right? So this IP address will not be a static IP address. Once you shut down a particular machine, the public IP address which is assigned will be automatically get returned back to the Amazon pool of public IP address. So you can just click on the Ubuntu server and you can see that there is no public IP address. Okay. Now, in order to do that, in order to do that, what we can do is that there is a concept which is known as elastic IP. Okay, so we can assign a elastic IP to a EC2 instance, and once an elastic IP is assigned, even if you shut down the particular machine, the public IP remains the same. Okay, so what is the concept of elastic IP? So we call it as EIP or elastic IP. So elastic IP is nothing but it will be a static public IP address. Okay. There is some limitations of this elastic IP address. The limitation is you can take maximum 5 EIP from AWS for a particular region. Okay, so suppose we are working on Ohio region. So for Ohio region, maximum 5 elastic IP address can be taken. Okay, elastic IP address is free. Okay, this is free, considering the fact that it is not allocated. So if you are allocating a particular elastic IP address to a particular EC2 instance, we can take elastic IP address, we can reserve elastic IP address, but it will not be chargeable unless and until we are allocating an elastic IP address. We are associating an elastic IP address to an EC2 instance. So in order to go for an elastic IP address, just go to the below section of network and security, click on elastic IP address. Okay, click on allocate elastic IP address. So it will be from the Amazon pool of address. Click on allocate. Okay, so once you are allocated an elastic IP address, you can see there is a public IP address which has been allocated. Now in order to use this public, you can see that there is no instance ID associated, there is no private ID or association ID. So in order to associate it, what we have to do is that select this, go to actions, click on associate elastic IP address, then click on instance name that you want to associate. So suppose you want to associate this elastic IP address with my Ubuntu server, click on Ubuntu, click on associate. Once you click on associate, and if you go back to the instance, the Ubuntu server which you are seeing that there is no blank, there is a blank public IP address. If you click that, you can now see there is a public IP address or elastic IP address which is configured and which is assigned. Okay, so the reason I have associated this with a stop state EC2 instance, because I don't want this to be charged. Okay, so is there any questions which is left, which is there with respect to elastic IP address?
So even after this Ubuntu server gets stopped and restarted, then
yeah, the server is stopped. The server is stopped.
No.
Stopped.
Yeah. So it will remain the same. I'm asking, like it will remain as a static.
It will remain static because now you have associated a static public IP address.
Sure. Yes.
Okay. Similarly, if you want to associate this public IP address with some other instance, first go to actions, click on disassociate elastic IP address, click on disassociate. Okay. Once you disassociate this IP, you can see if you go back to the EC2 instance, now the public IP address is removed. Okay. Now if I go back to the elastic IP address and then associate this with suppose one of my Windows server. So before doing that, let me show you one thing. This is the public IP address of the Windows server. Okay. This is the public IP address of the Windows server, and let me assign the elastic IP. So what is the elastic IP? Elastic IP is in 18 dot series. So action, associate elastic IP address, go to click on Windows, click on associate. Okay, it is now associated. Go back to the instances. Now click on Windows, You can see now it is changed to the 18 series IP address. Now, what will happen if I suddenly disassociate this IP address? Can anyone tell me? This Windows machine is running. This Windows machine is running currently, right? Now, if I disassociate and static public IP address from a running EC2 instance, what will happen? Will it get an IP address or not?
It will get an IP address, but different from the previous one.
Exactly. So if I go to elastic IP address and now disassociate this elastic IP address and go back to my Windows instance, okay, and see it, there is, just a minute. Can you see? There is a different set of IP address which it has got. 18.217. What is my elastic IP address? 18.217, 197.132. It has now got a different set of IP address. And this has been again changed back to dynamic public IP address and not a static one. Okay. Now let's see whether our snapshot is complete or not. Go to the snapshot. Okay, now the snapshot is complete. Now let's see how we can create an image. So you can create an image directly from the EC2 instance, okay, or you can create an image from the snapshot itself. So before doing that, let me add this 100 GB instance to my Windows server. Okay, let me add this 100 GB instance to my Windows server. So in order to do that, actions, click on attach volume, click on, just a minute, I think it's on a different location. US is to B. Okay, I think this is on a different location. Okay, so now it's on a different location. I think we cannot change the availability soon. Just a minute. Okay, just do one thing. US is to A, go to the volumes, go to this volume. Let me remove this volume first. Delete volume, yes, delete. Okay, and then click on create volume. So instance is on. US is to A. Create another volume in US is to A. I don't need a snapshot. Create volume. Close. Okay, I have got my 100 volume. This is my Windows add-on volume. Okay. Next action, attach volume, select the instance, click on attach. So now it is attached. Okay. So do you guys want to see, like the way we have seen how we can allocate a particular volume in my Ubuntu instance? Do you guys need to see how we can allocate the volume in Windows instance, or it is fine for you guys? Guys?
Okay, but just tell me how much volume I can add with the EC2 instance.
That totally depend on the instance type.
Okay, if it is a T2 micro, then how much?
If it's a T2 micro, maximum 100 GB of volume, a single volume which can be of 100 GB you can attach, and out of with 100 GB volume you can attach maximum of 5 volumes. That means 500 GB you can attach, and a single volume should be not more than 100 GB. So you guys don't want to see the disk management section for Windows, right?
You can show.
Okay. So for doing that, let's log in back to our EC2 instance.
error about 33.
Yeah, Daniel?
The error on that page about 3389, is that regarding the security group for that particular instance, or is that just that?
Let me see whether the security group is added with 3389 or not. Yeah, 3389 is added.
Yeah. Okay.
Let me directly connect with the public IP address. Yep, got it. Administrator. Then let me see the password. Decrypt password. This one is there. Let me log in. Okay. Now, in order to attach a particular volume in Windows, you have to go to start run and you have to give a command disk mgmt.msc. So this is a disk management option. Okay. So now you can see that the 100 GB volume which is there, which you have attached in the Windows server, it is now showing offline. Okay. So first you have to right click and click on online. Once it is online, you can see that it is not initialized. So you have to right click and then click on initialize disk. Okay. Now once it is initialized, you can right click and create a volume or a drive for this particular. You can select any of the drive names like D drive, click on next, click on, so this is Windows add-on, click on next, click on finish, and you have your drive ready. So if you now go to your Windows Explorer, you can now see there are two drives, C and D. D is 100 GB and C is 30 GB. Okay. So this is the way. It is pretty simple in Windows rather than in Ubuntu. Okay. So let me log off. Now let's take a snapshot. Let me show you what is the reason I added a volume. If you want to create an image of this, you can select here. You can right click. You can go to images and template, and you can click on create image. Now, if you click on create image, can you see there are both the volumes are actually showing. It is showing the root volume as well as it is showing the EBS new volume which you have attached. Okay. At the same way, if you go to the snapshot, if you right click it, click on create image, it will only show you the root volume. So the difference between creating an image from a EC2 instance and thus creating an image from a snapshot is, once you are creating an image from a snapshot, it is only taking the system state image backup, or it is only taking the system state image backup. For that reason, it is only selecting the root volume. Okay. Now suppose you want that once this particular image will be deployed into other machines, those other machines will get another 50 GB of volume added. Okay. So in order to do that, just right click on it, click on create image. Okay. Give the name of the image, like say custom win image. Okay. Click on add EBS volume. You want to add another 50 GB of volume to be added. Okay. So 50 GB of volume will be added, and the image will be created with the configuration of whatever the configuration that is there in this particular snapshot. It will create this, plus it in that particular image it will also add another 50 GB of volume. So once you deploy this particular image to other machine, this root image of 30 GB will be created, as well as there is a 50 GB of extra EBS volume will be created. Okay, so let's see, click on create. So your create image request is received. Okay, now from where you can get this particular image, if you just go to AMIs, this is your custom Windows image. This is your custom Windows image which has been created. Okay, now if you want to deploy up this particular custom Windows image which IIS configure for another machine, what you can do is that click on launch. Okay, or I will better show you from the EC2 console. Click on launch instances, go to my AMIs. On the my AMIs, you will see the custom image, custom Windows image which has been created. Click on select T2 micro, next, next. Can you see? The extra 50 GB which you have configured in that particular image, that 50 GB is already taken. Any question? So if you just click on review and launch, it will launch the same Windows server with an extra 50 GB of EBS volume with IIS enabled. So this is the same way. Yeah.
When the image launches, is the 50 gigabit drive, is it going to be initialized?
No.
You have to go in.
No. When the image will be launched, when this new image will be launched, it will just attach the 50 GB volume, 50 GB EBS volume. You have to again go back to the disk management section and you have to initialize the disk, create a simple volume, and then you can use it.
Because that's a local operation you have to perform in the Windows, right?
Exactly. But if the same thing that you want to, if you want to do the same thing via Terraform, in the Terraform script, you can actually write the script in such a way, like it will take the image. Once the image is deployed, it will also create the particular EBS volume and initialize the disk and create the directory for you. So this is possible with the help of Terraform, but not possible with the help of GUI. Okay. So I'm not launching this instance because it will launch the same instance which we have created. Okay. So we are not launching this instance. Fine. Any questions up to now? Okay. Great. So that is what is there with respect to EC2. Now let's move to ELB or Elastic Load Balancer. Okay, so that's okay from your side. Anyone is having any question, you can just clear it. Fine. Now let's go to the Elastic Load Balancer. Okay, what is Elastic Load Balancer? Now, what is ELB? Elastic Load Balancer is the scenario, like if you want to create a particular scenario like this. Suppose you have 3 EC2 instance which you have deployed for a particular application. Okay, this is 1, this is 2, and this is 3. Okay. Now, first of all, elastic load balancers are region specific service. Okay. So ELB created in one region, you cannot access that particular ELB from another region. Okay. Uh, okay. Now, suppose you want to deploy this 3 servers and you want to deploy it in a scenario like this server will handle your 70% of load. Okay. This server will handle your 10% of load. And this server will be handling your 20% of load. Okay. If you want to deploy in this way, how you can deploy it? So there are 2 ways of deploying it. Either you can deploy a elastic load balancer for these 3 servers, or you can create it like once the load increases from 70%, means once it goes from 70 to 70.1, a second instance will be launched. Okay. Once the load goes from 80 to 80.1, a third instance will be deployed. And likewise, once the load goes down to below 80.1, below 80, this instance will be stopped. And like if it goes down to below 70, this instance will be stopped. So if you want to deploy it in this scenario can only be deployed with the help of auto scaling, which we will be discussing it tomorrow. Okay. But in the ELB, you can also deploy it like this, but not in this kind of a logic. In ELB, what you can do is that basically there are 4 types of ELBs which is currently there. I will give you the name of the ELBs. What are the 4 types of ELBs which are there? First is a classic LB. Second is application LB. Third is network LB. And there is another load balancer which has been introduced in May 2021, which is known as gateway LB. So these are the 4 types of LB which are configured, which you can actually configure, So what classic LB does? Classic LB distributes the load equally among all instances in a round robin algorithm. Okay. So what it will do is that suppose you have 2 instances. Okay. This is instance 1, this is instance 2, and if it is there in ELB, and if it is there in a classic ELB, it will distribute the load equally. Okay. So for our scenario, we have 2 servers, 2 EC2 instance. One is a Wordpress, another is a Joomla. Right. What we will do is that we will create a classic ELB and we will see how the load get distributed between Wordpress and Joomla. So what happens is that once you create an ELB, there will be a DNS which will be created for this ELB, and any user who wants to access this particular applications will not be accessing these applications IP addresses, public IP addresses, or your DNS name. Rather, they will be accessing the ELB DNS name, and ELB based on the logic will, like what will happen in the hands-on scenario, I will tell you. Once we will configure this ELB and add this Wordpress and Joomla server, First, when we will click this particular DNS, it will show the WordPress web page. Okay. Second time, when we will click this DNS, it will show the Joomla web page. Third time again, when you will be clicking it, it will again show the WordPress web page. Since it's the 50% scenario, it's the 50% load balancing that it is happening. For that reason, you will see that every click that you make, it will shift the page from WordPress to Joomla and from Joomla to WordPress. Okay, let's see how we can do it. So in order to do that, like again, I will show you what are the pages that is there. So for Joomla, this is the page that you will see once you run it. And for your WordPress, this is the page that you will be seeing it. Okay. Now, in order to go deploy an ELB, you have to deploy it from the EC2 console itself. You have to go down and you have to click on load balancers. Okay. Then click on create load balancers. So you can see there are 4 types of load balancers which are there: application load balancer, network load balancer, gateway load balancer, and classic load balancer. Okay. One thing that I missed, in load balancer in a classic ELB, there is no concept of logic port forwarding. Like suppose you want that if the traffic comes to port 80, then it will go to this server, or if the packet comes from port 8080, it will go to this server. There is no concept of that, as well as there is no concept of load balancing with the help of protocol. That means if this particular packet is coming from for an HTTP, okay, so if an HTTP packet, HTTP protocol is initiated, it will go to WordPress, and if an HTTPS is selected, it will go to Joomla. So there is no concept of logical reasoning in case of a classic load balancer. Classic load balancer is a simple load balancer which will equally distribute the load among all the instances which are there under the load balancer. Okay. So let's see it, how we can do it. Click on create. Now you have to give a name of the load balancer. Click on classic. Classic. Okay. Now create an internal load balancer. Now this internal load balancer is only be done in a scenario, in a multi-tier architecture scenario. Now what is a multi-tier architecture? In a multi-tier architecture, suppose this is your internet. Okay, there is a load balancer which is present here, which is actually internet facing. So in this load balancer, suppose this is a particular switch. Under this switch, this is the application server, or suppose this is the web server which is connected to the internet. From this, there is a load balancer, internal load balancer which is defined. Under this load balancer, there is one application server and there is one database server. So what will happen? Traffic will coming from the internet. Maybe the user is sitting here. Okay, the traffic is coming from the internet. It will pass the load balancer, the internet facing load balancer. It will go to the switch and it will hit the web server which is internet facing. Okay, the web server will take the request from the internet facing load balancer and it will flow the traffic from your internal load, from your internet load balancer or from your front end server to that of the backend load balancer. Now this load balancer is not public facing. This load balancer is not public facing. It is an internal load balancer. It doesn't have any public IP address assigned to this particular load balancer. Once this particular packet is received in the load balancer, this load balancer will, based on the logics or based on the policies that is defined, it will send the data to the application and to the DB. So this is a classic example of a multi-tier architecture. for where you can define an internet facing load balancer. Any load balancer which you create, if you are not specifically saying that this will be assigned as an internal, it will automatically be assigned as a public load balancer. So if you click an internal load balancer checkbox here, then only this load balancer will be used as a public, as a private, and you cannot access this load balancer publicly. If you uncheck this, by default, this load balancer will be getting a public access. Okay. Now, what is the traffic that we need? We need HTTP 80 port 80 traffic. Okay. That will be coming for this instance protocol. Next, click on assign security group. We can create a new security group where we can say that any packet coming to port 80 for any subnet and any network, it will be allowed. Okay. If you have an existing any security group which is created, you can also use that existing security group. Okay. Click on next, configure security settings. Now, what is health check? So let me go to my annotation mode.
It will check the servers are up or not.
Exactly. Exactly.
Yes.
Now, suppose you have created a particular ELB. Okay. And you have defined 3 servers. Okay. Server 1, server 2, server 3, and this is a classic ELB that you have defined. Okay. So in case of a classic ELB, what will happen? The load will be distributed among all these 3. That means 33.933% load will be taken by all these 3 machines. If I take it on a graph, okay. So once 33.3% is over, the load will be automatically transferred to second machine and likewise to the third machine. Now, how will it identify that these servers within the ELB are actually active or not? Okay. So in order to identify that, ELB will do a ping on a port number that you will configure on a particular ping path. That means since these are web servers, so definitely for each and every web servers, if you are deploying it on a Windows machine, there will be an index.html file. Okay. So for every 5 seconds, ELB will generate a ping over the port 80 to this particular machine. Okay. Now, if within 5% this particular instance doesn't give a reply, okay, which is known as an unhealthy threshold. Okay. Now, healthy threshold means minimum. Healthy threshold means maximum 10 reply. If the ELB receives maximum 10 reply, it will understand that it is this particular node is healthy. Okay. Now, even if he receives a minimum of 2 response, then also it will understand that this particular port is actually, this particular ELB is actually ready to receive packet. Okay. Now, if it doesn't receive any response within a period of 5 seconds, okay, automatically it will put this machine as unhealthy state and will take this machine out of the ELB instance. Okay. And then the load will be shared instead of 33.533%, then the load will be shared in a form of 50%. Okay. Now, every 30 second interval, this ping port over 80 it will be continued. Okay. Now, even if after, let's say after 1 minute, this server goes up. Okay. This server goes up. So what will happen is that the response time, it will start pinging the response time. Once the response time is received by the ELB, it will again reattach this particular server back to the ELB state, and it will diminish the 50% load to 33.33% again. Any questions on health check? Any question, guys?
Okay.
Great.
So I'm sorry, I missed. What was the healthy threshold? Does that mean 10? It has to happen 10 times before it's healthy again?
Yeah, exactly.
Oh,
Once a particular server goes down, means once a particular server is actually showed as unhealthy, next time this particular server which is shown unhealthy have to give a 10 healthy response in order to make the server again back to healthy state. That means suppose this server 1 is now up, so it will not take this two unhealthy, minimum two unhealthy state it will not take. It has to be have a 10 healthy responses or 10 ping responses back to the ELB. Then only the ELB will put this server back to the healthy state and it will put it back to ELB within the ELB. Is it clear, Daniel?
yes, thank you.
Yeah. Okay. Now, okay. So let's keep it this. Now go to next and add EC2 instance. So what are the EC2 instance that I will be adding? I will be adding the Joomla one and I will be adding the WordPress one. Okay. These two instances I will be adding inside the ELB. Next, add tags, review and create. Click on create. Okay. Successfully created load balancers. So just a minute, guys. Click on close. Okay. Now see. This is the classic load balancer which is created. Okay. If I go to instances, it is showing as out of service. The reason behind this, it is showing us out of service because once these two are a new instances which are added. So it will run this health checks. It will run all this health checks which you have defined. Once this health checks are passed, then only it will show you as in service. And unless and until these two instances are showing as in service, we cannot work on the ELB instance. Okay. So it will take around a minute or so in order to make it in service. And even if you want to add other instances, you can click on edit instance and you can add many other instances as well. Okay. If you go to health check, you can also change the health check settings out here. You can check the listener port apart from 80. If you want to listen with some other port, you can click on edit, you can click on add, and you can add other listener ports as well. For monitoring purpose, it will give you a graph-like scenario. Okay, like what are the unhealthy hosts, what is the average latency, what is the request, what is the backend connection it is, or you can configure all this in CloudWatch. So let's wait for some time in order to get this as, and this is the DNS name that we were talking about. This is the DNS name.
One thing.
Yeah.
In that security group, is ping allowed?
No. No.
Then how the
First and foremost, it is actually not pinging the instance. Okay. There is one thing which you need to change actually. Now, since these are classic load balancers are with WordPress and Joomla, index.html is not present in WordPress or Joomla. It is actually in Windows. Okay. Now, if you don't know the exact file which needs to be pinged, you can just put a simple slash. So it will automatically go to the root directory and it will ping the particular file which is required to run this particular web server. So in case of WordPress or Joomla, it will be index.php. In case of Windows, it will be index.html. So it is actually not doing the ICMP ping, Abhijit. It is pinging the
protocol will be different.
Yeah, the protocol will actually do a protocol ping over the path which we have shared.
Got it. Because it's a classic load balancer. If it is a network load balancer, then obviously it would be a
Then it will be over the ports, and you have to allow. You need to allow the port numbers which you need to ping. So now this is in service. Okay. And again, guys, showing you these are the page which you will be showing. Now let's see what is the thing that we can see. Go to this description. Yeah.
Sorry to interrupt you.
Yeah.
I have to leave. I'll go through the recording tomorrow.
Yeah, sure,
Okay.
Kanchan. No issue in that. No issue in that. Okay, so this is the classic DNS name. So click on this DNS name and let's put it in the web page. Can you see the Joomla page? You can see the Joomla page, right? And if you open in another incognito window, can you see the word page? Okay. Again, if you just close this, again, if you go to another incognito window, you will again be seeing the Joomla page. This is the word page. Okay. And now go here. This is the Joomla page. So this is the way the load is getting transferred. Okay. I'm not sure whether it will show you in the monitoring one. There is no unhealthy host. Can anyone try using this link and see what you guys are seeing, whether you are seeing the two pages or not? Just ping this, just put this in your web browser and see what is the page that you are getting. Means I just want to make you guys confident enough that ALB is actually working, and you are actually browsing the same DNS name, not a different DNS name. Let me know what is it showing.
Showing Joomla for me.
Can you open another browser and then again paste the same web page, same link?
I can see WordPress.
Okay. See, one is saying Joomla, one is seeing WordPress. So the load is actually getting distributed. Now let's do it in a different way. Let's add the Tomcat server. Save. It is out of service. It will take some time. So now the load should be distributed with a 33.33% balance. So that means first time you will see the Joomla page, then it will show you the word page, and then it will show you the Tomcat page. Let's see. It is showing me the Joomla one. I am opening incognito window. This is the Tomcat page that it is showing. You can see the Tomcat logo. Okay. Again, I'm going here. It is showing me the WordPress page. Is it clear?
Yes, it's clear.
Okay. So let us take some break of around it's 8:25. Let's come back again on 8:45. Okay, let's take a 20 minutes break, and by that time you can actually practice this. And then once we come back from the break, we will be working on the network load balancer. I will show you how we can work on a network load balancer. Is it fine?
Yes.
Okay. So let me start the timer for 20 minutes. See you guys in 20 minutes. Guys, can you quickly confirm whether everyone is back? Guys, can you confirm?
Yeah, I'm hearing.
Okay. Avijita, Milan, Atanu, are you guys back?
Back, I'm back.
Okay. Okay. Fine.
Yes, sir.
Okay. So now let's start with application load balancers. Now, before doing that, let me go to the load balancer. Let me delete this load balancer so that we don't have any confusion. Okay. Now let me go to back to my whiteboard. Now, what is a network load balancer? Like I told you that in a classic load balancer, we cannot create any logic based on ports, based on protocols. We cannot create any logic, right? But in network load balancers, we can create such logic. Okay? Suppose if I take a classic example, suppose we have 3 servers defined here. Okay. Now, for this, we have Wordpress, we have Joomla, and we have Tomcat. Now, WordPress is working on port 8080. Joomla is maybe working on port 8081. Okay. And Tomcat is working on port 8080. Okay. Now, if you want that any packet which is coming over port 80 will only hit WordPress, and likewise 8081 and 8080 will be having their respective applications, that can be done with the help of network load balancers. But in network load balancers, the main thing which is required, not only network load balancers, in ALB also, there is one common thing which is required in order to do such kind of a configuration, which is known as target group. Okay, we call it as TG. Okay, so TG is target group. Now, what is target group? Target group is actually a container where we can add numerous instances. It can be 1, it can be 3, it can be 1,000, it can be lakhs. Okay, and each and every network or an application load balancer will push the packet on those target groups, rather pushing the packets to the individual EC2 instance. Okay, so suppose what we can do is, suppose we can create 3 target groups. Okay, we can create 3 target groups. Let me name this as web target group, as Joomla target group, and Tomcat target group. Okay, remember one thing, a EC2 instance within a target group can be a member of multiple ELBs, but A single target group can be a member of a single ALB only. Is it clear, or is there any confusion on this?
Can you relate it again?
A single EC2 instance, like this this WordPress EC2 instance, this can be a member of multiple ELBs. Like it can be a member of a classic load balancer, it can be a member of an application load balancer, it can be a member of a network load balancer. Okay, but if we are assigning this web target group to a particular network load balancer, the same target group we cannot use it in another network load balancer, or we cannot use it in another ALB. Okay. So what is the target group? What is the function of the target group? The function of the target group is to distribute loads between application and network load balancer. You will see it when we will be doing it in the hands-on session. But is there any confusion about the functionality and the way target group works? You can ask me again.
Actually, like a bit confusing. Like the definition of load balancer itself says that like distributing the loads between the series or whatever. Like so, here the target groups are also distributing loads among the load balancers.
No. There is a difference. In classic load balancer, where the loads are distributed, it is distributed directly over the EC2 instance.
No. Sorry. Like in classic, I mean, we are distributing the loads amongst the. I think you can go back. Like,
This is a classic load balancer, right?
right.
In a classic load balancer, we are
Instance,
distributing the load directly over the EC2 instances.
Right.
But
Yeah.
but in a network load balancer, we are not distributing over the EC2 instance. What we are distributing? We are creating target groups. Okay. This target groups contains numerous EC2 instance. Okay. So the load is actually distributed over the target group, and from the target group, those loads are actually replicated to the EC2 instances. Okay. So
Not directly to the instance.
not directly to the instances. And this target group, suppose if we create a say in name ELB known as NLB, the name of the ELB is NLB. So this TG1, this can be only attached to this NLB. If you create another NLB as NLB1 and you try to attach this target group, so first you have to disassociate this target group from the previous NLB, and then only you can attach this target group to the new NLB.
Only one time exactly.
Yeah, but any EC2 instance declared here, okay, this EC2 instance can be part of a CLB, a classic, it can be part of any NLB, or it can be part of any ALB.
Good.
Got it?
Mm.
It will be much more clear when we will see in the hands-on. Okay. Now, in order to define a target groups, so in an application load or a network load balancer, okay, so the scenario will be, let me draw the scenario for you. So this is the NLB. We have WordPress, we have Joomla, and we have Tomcat. This is working on port 80, this is working on 8081, and this is working on 8080. Okay, and we have 3 targets group which is defined. Okay, this is TG1, this is TG2, and this is TG3. Okay, so we will see that if we try to ping the DNS of the NLB based on port 80, we will see the web page of Wordpress. If we use it with 8081, we will see Joomla, and if we see 8080, we will see Tomcat. Okay, now, so in the EC2 console itself, go to the target groups. Okay, let's first create one target group. Now, once you create target group, there are 2 types of options which you get. One is the instances. That means you can directly attach the instances inside the target group. Now, if you have VPCs, like different custom VPCs, if you have VPCs from other regions, if you have EC2 from other regions which we want to add into this network load balancer, so you can directly use the IP addresses or public IP addresses of those EC2 instances, and you can add it part of the target group, or you can use a lambda function. So lambda is nothing but this is the serverless architecture of AWS. Okay, so we can define lambda functions in order to deploy serverless architectures. Like if you want to deploy some database servers, but you don't want to create any EC2 instance, but want to deploy it in a serverless environment, so we can use lambda. We will be seeing it in the later part of our discussions. Okay, now for this we will be creating an instances. Let's name the target group as WordPress target group. Okay, so the port will be HTTP 80, right? It will be 80 port. Fine. Protocol will be HTTP 1. This is the health check. Click on next. Okay, now you can add the instances out here. Now first instance will be WordPress. Click on WordPress. The port will be 80. Click on include as pending below. Okay, now click on create target group. Now my first target group is created. Let's create the other 2 target groups. Second target group will be Joomla target group. The port will be 8081. Okay, the port will be 8081. Click on next. I will be adding the Joomla one. The port for selected instance is 8081. Okay, include as pending below. Create the target group, and then create another target group known as Tomcat target group. Protocol will be 8080. Okay, this is the Tomcat. Oh, sorry. This is Tomcat. Port will be 8081. Include as pending below. Create target group. Now, can anyone tell me there is one configuration which is required for all these 3, rather 2, I will say, Joomla and Tomcat, because unless and until that configuration is done, this ALB will not work, this NLB will not work. What is that particular thing that is required to configure? Vijita?
Is it health
So
check?
we need to configure the security group.
Exactly.
For the ports?
Exactly. Because if you go to these instances, this 8081 port is not allowed in the security group. So even if we try to create a ALB with this port number, the health checkups will not happen because the health checkup will be unable to reach 8081 port for the Joomla target group. So for that, let me go to this security, go to this instance. Okay, go to the security, You can see 8081 is not defined out here. Okay. Now go to the security section, then have to go to the instances, click on this, click on Joomla, go to the security section.
It's time for bed.
Go to the security group. Here the port is not defined. Click on edit inbound rules. Okay. Click on add rule, custom TCP port. What is the TCP port which Joomla is using? Joomla is using 8081. Click on 8081. Give it as anywhere IPv4. Click on save rules. Okay. So now 8081 port is added. Again, go back to the target groups. We have to do the same thing for the Tomcat. Okay.
I think port numbers is in the target groups has and yeah, it's changed. I think 8073, 8076.
Pardon?
And the port numbers of the like if you go to the target group, yeah, port numbers 80 instead of 8081 or 8082.
Oh, we need to save it again. Actually. Open it and we need to save it. When you have created the security group, I have seen that it was missed. You can go and
Okay.
change it again.
Okay. Let me see. No, 8081 is added.
No, not here, not here, not here. Go back to that security group portion.
Yeah, this is the security group portion for the Joomla.
Target group, sorry, yeah, target group.
Okay.
Yeah, the port of
Certain Tomcat target group, this port number is 8080. This will be 8081.
Yeah, it is 8081.
Then is it a source port or destination port? This one, which is mentioned over there.
This is the
Port
source and
number
the destination,
8076.
both source and destination port.
Then why it is showing 8076 or 8073?
This is the protocol port. This is the protocol port with the help of the which target group will see, target group will assign the packets.
Okay.
oh,
Okay, so this is something different.
I see.
So even if you want, if you have confusion, let me delete it, create a target group, let it be as port 80. So it will be WordPress target group, click on next, WordPress, include as pending, create target group, WordPress is created, next go for Joomla target group, okay, click on next. So here let's add for Joomla, it will be 8081, okay,
No,
8081.
go back. It's okay. It is port number.
For Joomla it will be 8081, right? Okay.
Go back once. Go back once. Previous. Go back previous once. Here HTTP port is port 80.
Okay. Sorry.
Now it seems fine.
Okay.
Now it seems fine. Right.
Now click on create target group. Okay. So Joomla target group is created. Next, go and let's create a Tomcat target group.
8080.
will be 8080. Next will be Tomcat, include a spending below, create target group. It is created now. Let's go to the instances and see whether the target groups are assigned or not. Click on target. Okay, so just a
But
minute.
click on the security group, na?
Yeah,
Uh-huh.
so this is for
Right.
Joomla one, right? So Joomla,
Right.
so Joomla is 8081. 8081 is added as a security group.
Yes.
Okay, go to the target groups again, go for the Tomcat one, click on targets, go to the security group, and this is,
Tomcat is 8080 or 8081.
yeah, Tomcat is 8080.
Then you don't need to go back there. I think it is 8081 written there.
Yeah, so just
But once go to security group.
edit
See,
inbound
it's
loads.
8081.
Yeah, so 8081, it will be 8080.
Yes.
Save
Right.
groups. Okay,
That's
so
fine.
8080 is now created. Okay, now let's go to the load balancer section. Okay, so we have deleted the load balancer. Now click on create load balancer, click on network load balancer. Okay, give the network name like previously we have given it as classic. So let's give it as network load balancer. Okay, so like the same we have defined it as internal and external, so it will be internet facing, it will be IPv4. Okay, so let's select all the subnets. Okay, now in the listeners we have to add for 80, it will be for 80, just a minute, IPv4 network mapping, fine, we have added all persons, all the subnets. Okay, now so it will be TCP. Okay, there is one wrong I have done. We have to go to EC2, we have to go to the target groups, click on this, then targets, this is HTTP, just a minute, I have done one thing wrong. Then recreate it. Yes. Okay. So now you're defining is if the request is coming over port 80, it will go to WordPress. Okay. Click on add listener. Again, if the request is coming to 8081, it will go to Joomla. Okay. Click on add listener. If the request is coming from 8080, it will go to Tomcat. Okay. It is instant and pressing. Click on create load balancers. View load balancer. Now go to the listeners. Fine. Everything is fine. So it is provisioning. So it will take some time to provision. Okay. Like around 5 minutes. It will take some time. It will do now. Can you tell? There is one thing which I have done a mistake is that, and I also forgot to tell you guys is that the difference between a network load balancer and an application load balancer is in network load balancer there is no port like HTTP. Means you cannot configure any port over HTTP or HTTPS or any other port. It will be only TCP or UDP. Okay. So it will be only TCP and UDP port which you can configure over network load balancer. If you want to configure with the help of protocols like HTTP and HTTPS traffic, you have to go with application load balancers. So that is the reason now since we have defined it as HTTP, when we are trying to define the network load balancer, we are unable to find the target groups because the target groups itself is created with the help of HTTP and not on TCP. Now once I change the protocol from HTTP to normal TCP or UDP, then I got the target groups. Okay. So let's wait for some time. It will take some time for the provisioning to happen.
And also, suppose the speed of the network load balancer will be higher than other load balancers,
Yes,
right?
network load balancer is actually a load balancer which is used where we have multi-million requests per second which needs to be processed. Like suppose you want to deploy a NTP server or maybe you want to deploy a high-end DNS server. So there we have to define network load balancers.
Okay.
So likewise, you can also configure the CloudWatch setting here. Now though the configuration of CloudWatch is not part of the solution associate program, but on the last day I will touch base this CloudWatch because this will be one part which this is one feature where you will be getting questions in the AWS associate exam, related questions of CloudWatch. Though CloudWatch in detail configuration is not part of the AWS solution associate program. Okay, like I was now it is active. Okay, so let's see, let's copy this DNS name. Okay, let's go hit and over port 80, let's just ping it. You are getting the WordPress. Okay, if you are doing it with 8081,
So on the target group, is the port that's listening, does that have to be actually for the application or is it just arbitrary?
No, that has to be for the application. Means that has to be the port number with the help of which you are actually configure your web application.
So the Joomla target group, can it still listen on, can the target group listen on 80?
Yeah, the Joomla target group can listen on 80 on port 80. If you configure the Joomla with the help to listen the packets over port 80, you can do it. That's not an issue. But then you have to configure the Joomla to listen over port 80. So we just have to wait. And another thing is that, can you see that in classic load balancers, we have health check defined inside the load balancers, right? But in case of a network or an application load balancers, the health checks are not defined inside the load balancers. Rather, the health checks are defined inside the target groups. Okay, so if you select the target groups, you have the health check defined here. So here, whatever the things that is happening, it is happening over the target groups only. So it's active. Let's see. It is showing as healthy. We have port 80 allowed. Okay, we got this.